Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be discussing the 17th problem from the Special Maths Contest 2024, the first round. We've gone quite far. So let's look at this problem. It says let x, y, z denote coordinates of a point lying on the sphere of unit radius. So unit radius means the radius of the sphere is 1. Okay. Centered at the origin. Okay, so this is the origin. So we want to find the minimum possible value of 2x plus 3y plus 6z. Okay, so basically, this is the sphere of unit radius. This is what it is. Okay, centered at 0, 0, 0. So now I want to pick points on this sphere and then perform this, operation on them, and which of these gives us the minimum value. Okay, so let's look at this. We can apply what we call Cauchy-Schwarz inequality. So I'll just write it out here. So you have x1 squared plus x2 squared plus xn squared, okay, multiplied by y1 squared plus y2 squared plus yn squared. This is greater than or equal to x1 y1 plus x2 y2 plus xn yn squared. Okay, so we can apply this here. If we apply this here, what do we have? You can see that 2 squared plus 3 squared plus 6 squared equals to x squared plus y squared plus, 2 squared plus 3 squared plus 6 squared, all multiplied by x squared plus y squared plus z squared. And so by Cauchy-Schwarz inequality, I'll just write the name. So Cauchy-Schwarz. Okay. So 2 squared plus 3 squared plus 6 squared multiplied by x squared plus y squared plus z squared is greater than or equals to 2x plus 3y plus 6z all squared. Okay. So 2 squared plus 3 squared plus 6 squared, this is 49. So record our picking points on the unit sphere. Okay. So it means we're centered at the origin. So it means x squared plus y squared plus z squared for any point on that unit sphere satisfies that this is 1. This is greater than or equals to 2x plus 3y plus 6z squared. Okay. So we can, take square root of both sides. And what do we have? We have that 7 is greater than or equals to the absolute value of 2x plus 3y plus 6z. Okay. What does this imply? This implies that minus 7 less than or equals to 2x plus 3y plus 6z less than or equals to 7. Okay. So we have this inequality. So we have that the answer is most likely going to be minus 7. But when does equality hold for the Cauchy-Schwarz inequality? Okay, so equality holds. So let's put it here. Let me write it in black. So equality holds when you have x1 over y1 being equals to x2 over y2. So equals to xn over yn. Okay. So equality in this case, we can find a point where equality will hold. So let's try and find a point where equality will hold. So we want something like so 2t. So basically, okay, let me put it this way. So we want x over 2 to be equals to y over 3 to be equals to z over 6. Okay, so let's say this is equals to t. So we want x to be equals to 2t, y to be equals to 3t, and z to be equals to 6t. Okay. So we can plug it into the equation of the sphere. And we have 2t all squared plus 3t all squared plus 6t all squared equals to 1. So that implies 49t squared equals to 1. That implies, okay, so t is equals to plus or minus 1 over 7. Okay, so it means for the point, for the case where it's going to be minus 7, we want, so let me scroll down. So it means a point of equality here is going to be minus 2 over 7, minus 3 over 7, and minus 6 over 7. Okay, so this would give us what we're looking for. So we can plug it in and actually see that it works. So let's just see. So 2 times 2 times minus 2 over 7, that's minus 4 over 7. 3 times minus 3 over 7, that is minus 10 over 7. 6 times minus 6 over 7, that is minus 36 over 7. Okay, this is equals to minus 49 over 7, which is equals to minus 7. Okay, so we have that equality holds at this point. So the reason why it's important sometimes, especially in a theoretical setup, to check for where equality holds, because it's not enough to just prove that the inequality has a possibility of equality holding. So in some cases, you might want to prove that the inequality is strict. Okay, so it's sometimes very important to explore that actually there exists in the cases of equality. Okay, that'll be all for this video. Don't forget to like, share, comment, and subscribe, and see you in the next video. Goodbye.